Hey, boys and girls, welcome back. It's Mr. Irwin. Congratulations, you made it. While algebra will continue to be part of our mathematical lives all the time, this is officially the final lesson in the algebra unit for sixth grade. So on your screen, you notice today we're talking about graphing functions. So if you want to grab a notebook, a sheet of paper, follow along with me, a place to record your thoughts, your definitions, and some examples, I'd be more than happy for you to join in with me. First off, we have a definition on the screen, a linear function. Now, last week we were talking about functions when we were dealing with the relationship between an independent and a dependent variable. And we used that relationship to create a table of values that showed the mathematical relationship between that independent and dependent variable. Today, we're specifically looking at linear functions. And what a linear function is, you're going to see a clue right here in the first word, linear. You should see line. A linear function is a function that when you graph it on a coordinate plane will always produce a straight line. And every function that you are going to be working with in sixth grade is a linear function. So a great clue for you to hone in on as you graph these functions is, did your graph create a perfectly straight line? If your line is perfectly straight, you should be good to go. If you did make an error somewhere, you get a graph that looks like a hockey stick or a lightning bolt or something with a bend or a crook in it, you know you made an error, so you can go back and check your work. Every function you graph this unit should be a linear function. It will produce a straight line. So here we go. Let's talk about actually graphing one of these functions. Our first example, we're going to graph the function y equals x plus 1. Graphing a function is a three-step process. Step one, we're going to create an input-output table or a function table like we did in our previous lessons. Now, a lot of the time with these function tables, you're going to have the opportunity to choose whatever input values, whatever independent variable values you want to use. So make this easy for you. Choose numbers that are, one, going to be easy to calculate in the equation, and two, numbers that will be easy to graph once we get to the coordinate plane step. So I always recommend starting with an input value of 0. So I'm going to take that 0 and I'm going to plug it into x. So instead of y equals x plus 1, I'm going to have y equals, in place of the x, I'm putting a 0 plus 1. And now I perform this calculation. 0 plus 1 gives me 1. So when x equals 0, y will equal 1. And now you're going to choose a couple more input values. I recommend choosing at least 4. And again, you can choose any values you want. I'm going to pick ones that are easy to work with. So the next easiest number I can think of to work with is an x value of 1. So I'm going to take that 1 and I'm going to plug it into x. Instead of y equals x plus 1, I'm going to have y equals 1 plus 1. Performing that calculation, then 1 plus 1 is 2. So when x has a value of 1, y will have a value of 2. Another input value, I'm just going to go right down the row. Nice, easy numbers to work with. Now I'm using an input value of 2, an x value of 2. So take that 2, substitute it into x. Y equals 2 plus 1 when I substitute that in. Now performing my calculation, 2 plus 1, I get y equals 3. So when x equals 2, y will equal 3. And we need one more input value. I'm going to choose a 3. Plugging that into x, y equals 3 plus 1. 3 plus 1 is 4. So when x equals 3, y will equal 4. So step 1, completing an input-output or a function table. Step 2, we're going to use that function table to create ordered pairs. Now, if you remember from our lesson on ordered pairs, every ordered pair has an x value. Every ordered pair has an x value followed by a y value. And I'm going to pull these numbers or these values straight from my function table. The input value will always be your x. Your output value will always be your y. So the first ordered pair I created, an x value of 0 and a y value of 1, I have the ordered pair 0, 1. 1, 2 for my next two values. Next I use an input value of 2, so that's an x value, and that gives me a y value of 3, ordered pair 2, 3, and then finally a 3, 4. So there are the ordered pairs I created for my function table: 0, 1, 1, 2, 2, 3, and 3, 4. Third and final step, you've probably guessed it, we're going to graph those ordered pairs on a coordinate plane. So I'm just going to quickly rewrite these numbers. They were 0, 1, 1, 2, 2, 3, and 3, 4. Those are the ordered pairs we need to graph. So if you need to, pause the video, create your own coordinate grid, or if you have access to a printer, you can print one of the blank ones off that are available to you on Brightspace. Once you have your coordinate plane ready to go, hit play again, and we're going to graph these points. All right, so our first point is 0, 1. An x value of 0 means we are going nowhere left or right from the origin, and a y value of 1 means we're going up 1. So I'm plotting a point at 0, 1. Our next ordered pair is at 1, 2, means we go 1 to the right and up 2. 2, 3 means 2 to the right and up 3. And then 3, 4 means 3 to the right and up 4. So there are my 4 ordered pairs plotted. The last thing I need to do, I'm going to connect these with a straight line. And if you graphed everything correctly, you should produce a perfectly straight line because this is a linear function. So that line is the graph for the function y equals x plus 1. All right, let's try another one out. Here we have the function y equals 2x. So let's walk through all the steps together. Step 1, we need to create an input-output table. So give yourself an input-output table. The input value is always your independent variable. It's the variable on the side of the equation where the calculation is taking place. So my independent variable, my input value is x for this problem. And then my output value is the dependent variable, the variable on the one side of the equation all by itself. In this case, it is the y. So y, again, is my output. Boys and girls, you get to choose any values you want to use as input values. So choose ones that are easy to work with. I always recommend using 0. Plugging a 0 into x, take that 0, plug it into x. 2 is touching the x, means we're multiplying. 2 times 0 is 0. When x equals 0, y will equal 0. Next, I'm going to choose a 1. That's easy to work with. 2 times 1 is 2. Plugging in a 2 next. 2 into x. 2 times 2 is a y value of 4. And then finally, I'm going to choose a 3. Plugging a 3 into x. 2 times 3 is 6. So I've created the ordered pairs 0, 0, 1, 2, 2, 4, and 3, 6. Let's go ahead and graph those. So 0, 0, right at the origin. 1, 2 is 1 to the right and 2 up. 2, 4 is 2 to the right and 4 up. And 3, 6 is 3 to the right and 6 up. I'm going to connect those points. Again, if you did everything correctly, you should produce a perfectly straight line because this is a linear function and mine is perfectly straight, so we're good to go. Boys and girls, that is the graph for the function y equals 2x. All right, let's try one more together. On the screen, we have the function y equals 1/2 x plus 3. So please work through it with me. Step 1, you need a function table. My input value is x, my output value is y. And now we're going to choose values that are easy to work with. Always recommend using a 0. So if I plug a 0 into x, 1/2 times 0 is 0, and 0 plus 3 gives me an output of 3. Now be strategic with what you choose. If I choose a 1 as my next input value, plugging a 1 into here, 1/2 times 1 is 1/2, and 1/2 plus 3 is 3.5. That ordered pair would work 1 and 3.5. However, graphing 1 and 3.5 is a difficult concept for a lot of students. If you want to avoid dealing with fractions when you're creating these linear functions or graphing these linear functions, when the coefficient on your independent variable is a fraction, choose multiples of the denominator. And that will always ensure you have a whole number to graph. So because my denominator is a 2, I want to choose multiples of 2 for my input value. So I'm going to plug a 2 in next. Plugging a 2 into x, 1/2 times 2, I'm going to work it out here on the side so you can see it, 1/2 times 2 plus 3. Multiplication first, 1/2 times 2 is 1, and then we have 1 plus 3. 1 plus 3 is 4. When I input a 2, I output a 4. Choosing my next value, again, remember multiples of 2 here will be easy to work with, so I'm going to choose 4 next. If I plug a 4 into x, let me erase this calculation so I have room to work. All right, so I have 1/2 into x. I'm plugging my 4, so times 4 plus 3. Multiplication first, 1/2 times 4 is 2, and 2 plus 3 gives me an output of 5. Finally, my last multiple of 2 I'm going to use is a 6. So let me erase this over here. And let's perform our calculation inputting a 6 into x. So we have 1/2 times 6 plus 3. 1/2 times 6 is 3, and 3 plus 3 is 6. So if I input a 6, I will output a 6. Ordered pairs I created then are 0, 3, 2, 4, 4, 5, and 6, 6. Let's go ahead and graph those. 0, 3 means up 3 from the origin. 2, 4, 2 to the right and up 4. 4, 5, 4 to the right and up 5. And then 6, 6, 6 to the right and up 6. Now I'm going to connect my points. Because this is a linear function, they should produce a straight line. And they do. So I'm good to go. Boys and girls, there is the graph for the function y equals 1/2 x plus 3. All right, on the screen I have two functions for you to go ahead and graph on your own. You may need to create another coordinate plane or print out another blank one. But go ahead, graph the function y equals 2 plus x, and then y equals 3x minus x. Pause the video while you complete your work. When you're done, hit play again, and then I will graph these and you can check your work to see how you did. Okay, hopefully you gave yourself enough time to graph both of these functions. So let's check your work and see how you did. Our first function, y equals 2 plus x. So I'm going to start by making my function table. My input value is x. My output value is y. I'm going to input a 0. 2 plus 0 is 2. When I input a 1, 2 plus 1 is 3. When I input a 2, 2 plus 2 is 4. And when I input a 3, 2 plus 3 is 5. So now I'm graphing the ordered pairs 0, 2, 1, 3, 2, 4, and 3, 5. 0, 2 is graphed here. 1, 3, 2, 4, and 3, 5. Connect the dots. And there is your graph, y equals 2 plus x. All right, the second function I asked you to try, y equals 3x minus 3. So starting with my function table, x and a y. Starting with 0, if I plug a 0 into x, 3 times 0 is 0, and 0 minus 3, that's a negative 3, which isn't even an option in the first quadrant of the coordinate plane to graph. So 0 is actually not a great choice here, and because we have control of what values do we use, we want to pick numbers that are going to be easy to graph. So I'm going to start with inputting a 1. 3 times 1 is 3, and 3 minus 3 is 0. When x is 1, y is 0. Next, I'm going to plug in a 2. 3 times 2 is 6, and 6 minus 3 is 3. Plugging in a 3 next. 3 times 3 is 9. 9 minus 3 is 6. And finally, I'm going to plug in a 4. 3 times 4 is 12. Minus 3 more is 9. Now we're graphing that function. 1, 0 means 1 to the right from the origin. 2, 3, 2 to the right and up 3. 3, 6, 3 to the right and up 6. 4, 9, 4 to the right, and up 9. Again, if everything went correctly, we should have produced a graph that is linear, meaning a perfectly straight line. So connecting my dots, mine are straight, except for I just messed up that last little piece. Let me redraw that line. There we go. And there is your graph for y equals 3x minus 3. At this time, make sure you complete the independent practice for graphing functions, take a picture of your work, and upload that file for submission. I'll see you guys next time.